Happy Thursday, everyone. I told you on Tuesday I wouldn't be here. Yesterday, you guys, we went over the last couple of problems that I didn't get a chance to go over on Tuesday, and then I also went through the homework assignment. So hopefully you have that one all done and understood. If you don't, remember, mark the questions, hold on till tomorrow, and I can go over those when we meet up again at the beginning of class tomorrow. Or you could go back and watch that video that's available on YouTube. Okay. Now, on this particular review, I did make a mistake, and I apologize. And I knew I was going to make a mistake, and as I was going to teach it, I realized that with numbers 1 through 6, I wanted you to do a little bit more than your instructions told you to do. Your instructions told you to classify each exponential function as growth and decay, and then tell me what the asymptote is. I wanted to do a little bit more. So here is what we're going to do on numbers 1 through 6. And these are the same things you're going to be asked to do tomorrow on the quiz, okay? Now, here's the difference. On this review, there were 6 of these. On the quiz, there are only going to be 4, okay? 4 of those. There are going to be 4 of these where you have to solve, and then there's only going to be 1 graph. So that's going to be 9 problems, so it's going to be a little shorter. It could be 8. I might just make 3 of these. I haven't quite decided. I will decide that between now and then. So here's what we're actually going to do, okay? Hopefully you've had time to maybe look at this. We're going to, like your instructions say, we're going to classify each as growth or decay. But these are the two we're going to do that are different. We're going to write the parent function, and C, state the transformations. And then D will determine the asymptote, okay? So here we go. Let's get started. But we are doing all 4 of those, okay? So first, how do I determine if it's growth or decay? Well, it's all about the base of my exponent. You see the base of my exponent right there? It's a 3. 3 is greater than 1. This is definitely exponential growth. Now, kind of right along with that, these next two, they kind of go hand in hand. The fact that that is your base of your exponent, that makes your parent function simply 3 to the x power. And what I said to you guys over and over again when we were doing this is anything that is not 3 to the x power is going to represent a transformation. So let's state these transformations. The first one you see is this plus 4. Now remember, it's in the exponent spot, so it's horizontal. And when it's horizontal, remember we said it's the opposite. So it looks like a plus 4, so it's actually a negative 4 horizontal shift. A negative 4 horizontal shift means it shifts left 4. But then you got this minus 1 that's outside, so that's vertical. And vertical is what it is. So a negative 1 vertical shift means it shifts down 1. Now, that leads us right into the last question. That last question is, hey, what's the asymptote? Well, the reason that last thing we answered affects the asymptote is because if a exponential function has vertical shift, it is going to change my asymptote, and that has a vertical shift of negative 1. So it's going to knock that asymptote down to y equals negative 1. Now listen to me. If I want full credit on naming the asymptote, you can't just say negative 1. You have to state it as a horizontal line. And you state horizontal lines using y equals negative 1. Okay? So there is all 4 parts of number 1. Let's move on to number 2. Number 2A. Remember, we are looking for the base of our exponent. Here's our exponent. That's the base of it. So what do you know about that 3/4? Well, it's definitely less than 1. So this one is showing decay. And again, right along beside that, if that's the base of my exponent, then my parent function is simply 3 over 4 raised to the x power. Everything that's not that moves right along into the next part of this, which is What is my transformations? Well, let's start right here. I'm multiplying by a positive 2. Well, remember, if I'm multiplying by something, that's representing a dilation, which is either a vertical stretch or a vertical compression. It's all about the number. It's greater than 1. This is a vertical stretch. A vertical stretch. But then also, remember where that minus 7 is. It's in the exponent, so that's inside. Inside's horizontal, and it's the opposite. That looks like a minus 7, so I know it's a positive 7 horizontal shift. So it's going to shift right 7. So let's go to the last part of this, and that is, well, what's my asymptote? Well, remember the last problem? If there is a vertical shift, it affects the asymptote. Well, there is no vertical shift. There's a horizontal shift. There's no vertical shift. So what that means is it doesn't affect my asymptote. Now, that doesn't mean it doesn't have an asymptote. It doesn't affect my asymptote. And my asymptote for all exponential functions, unless it vertically shifts, is y equals 0. So that's what this one is. It's right on that x-axis, y equals 0. It cannot go below that x-axis. So there you have it. That's number 2. All right, let's keep on cruising along here. Number 3, A. Remember, we're trying to identify what is the exponent and its base. Well, that's a 2. 2 is greater than 1, so this one is growth. And it falls right along with that next one. My parent function would simply be that base raised to the x power. And anything that is not that is a transformation. So let's name them all. Well, I'm multiplying by 1/3 out in front. Well, that's definitely less than 1. So that's a vertical compression. Vertical compression. Then I got this minus 2, where? Inside. That's horizontal. Horizontal is the opposite. So minus 2 is actually a positive 2 horizontal shift. So this thing is shifting right 2. Shifts right 2. And then, of course, this one right here is my vertical shift. It is what it is. So this thing is a positive vertical shift. So it shifts up 4. Now, again, we move naturally into my horizontal asymptote, which we said is affected by my vertical shift. It went up 4. So my new asymptote is y equals positive 4. Number 4. Again, we are starting with what is this? Is this growth or is it decay? Well, look at your exponent and its base. That's a 5. This is definitely growth. Okay, next, we're going to state this as a parent function. Well, that is the base with its exponent, so 5 to the x. Moving along, when it comes to our transformations, C, we're going to name anything that is not 5 to the x. So there's a plus 1. Inside, that's horizontal shift. It's the opposite, so it's a negative 1 horizontal shift. That means it shifts left 1. And then, of course, this plus 2 is outside. That's vertical. That's a positive 2 vertical shift. So this thing shifts up 2. Which, again, goes right on into our asymptote. If we had a vertical shift, it affects this asymptote. We sure do. So this thing has a new asymptote of y equals positive 2. Okay? We are rolling. Look at number 5. Number 5, what is the base of that exponent? 1/2. Well, if it's a 1/2, this thing is definitely decay. Now, if that base was 1/2, my parent function is 1/2 to the x power. Anything that is not that is a transformation. So the only thing I have that is not 1/2 to the x power is minus 6. Now listen. Where is it? Well, it's clearly down to the right. It's not up here in the exponent. It's down and to the right. That's vertical shift. It is what it is. So this thing shifts down 6. And on top of that, because it is a vertical shift, it's going to affect my asymptote. So my asymptote drops down to y equals negative 6. Okay? Easy does it. Now, number 6 is almost too easy. I can guarantee you won't have one this easy on the quiz tomorrow. Look, it literally is the parent function. Well, that base is a 2, so it's definitely growth. It's the only thing there, so the parent function is itself. Therefore, it has literally no transformations. None. Right? And if it had no transformations, that means it did not have a vertical shift. So therefore, it was unchanged. So y equals 0. So I'm not going to give you one that easy. But that is answering all the questions for the new instructions that I gave you. A, we're classifying each exponential function as growth or decay. B, we're writing the parent function. C, we're stating the transformations. And D, we're determining the asymptote. So please remember that those will be the exact same instructions on the quiz tomorrow. So you need to have a good understanding of every one of those because they'll all be on there. The only thing that we left out was reflections. Remember, if there had been a negative out in front, for example, if there had been a minus sign right here, negative, that one would have reflected over the x-axis. So again, we talked about those. You should remember them. All right, let's move along. And on number 7 through 10, we are solving exponential equations. This is exactly what we did on Tuesday and Wednesday. So we're following the same rules. Let's start with number 7. Remember, number 7, and again, I'm going to give you 1-to-1 on these. There are 4 on this review. There are 4 on the test. The one that looks like number 7 will be very similar. Same for 8, 9, and 10. I'm not putting anything on here that is just too difficult. If you notice, I'm not putting anything on this test where you have to combine on each side. We're keeping it real easy, okay? I'm not trying to give you guys something that is just crazy hard. I might give you a bonus that is hard, and it will be the type that you are welcome to try if you'd like, but it won't count against you if you don't figure it out. So let's start with number 7, the easiest of all. Why? Because you literally have the same base on both sides. So like we said the last couple of days, we drop the base. So that will leave me with 3x minus 5 equals x plus 9. And all I have to do is solve. And you guys have been doing this for a long time, so let's do it. Which one do I like moving, the 3x or the 1x? Well, I like moving the smaller one. So I'm going to move that 1x by subtracting x. So 3x minus 1x is 2x. Minus 5 equals 9. And now I'm going to solve for x. How do I do that? Well, I add 5. So 2x equals 14. And then I divide by 2. So x equals 7. And that's it. That's all there is to that. So, very simple one to start with. You will have one very similar to that on your quiz tomorrow. Number 8. A little harder because, look, they're definitely not the same base, right? This one has a base of 2. This one has a base of 4. So we're trying to make those the same base. Well, again, like we talked about yesterday, I'm going to try to make that bigger one, 4, have the same base as 2. Can I? Let's see. 2 times 2 is 4. There it is. So I can change 4 to 2 squared. Now remember, on the other side, I don't need to do anything with it. It's already 2. So now that I have the same base, what can we do? We can drop the base. So now I take 2x plus 10 and I set it equal to 2. And it's solving. So to get x alone, because I don't have a variable on both sides, to get x alone, I need to move the 10, subtract 10. 2 minus 10 is negative 8. And then I got to divide by 2. So negative 8 divided by 2 is negative 4. So my answer is x equals negative 4. All right, moving along. Let's scroll down here to number 9. Very similar to that last one, except look at my bases. This one I have a base of 5. This one I have a base of 1/5. Now, obviously, you notice it has the 5, right? It has the 5. But those aren't the same bases, right? Look, this one's a fraction. So yesterday and the day before, we talked about how we can make this a base of 5 by using a negative exponent. And since it's exactly 5, we're just going to use negative 1. Now on the left side, it's good. I don't need to do anything with it, just like I didn't on the previous problem. So I can drop my bases, and 4x plus 15 equals negative 1. So I'm going to solve this one. First of all, I'm going to subtract 15. So negative 1 minus 15 is negative 16. And then I'm going to divide by 4. So negative 16 divided by 4 is negative 4. And that is my answer. Again, I did not choose difficult problems because these are the ones that are tested as far as we're aware, and therefore I'm trying to keep them just as simple as you're going to see them. So let's look lastly at number 10. Again, look at my bases. I've got a base of 4 and I got a base of 64. I'm going to try to see if I can make 64 a base of 4. So I'm going to do 4 times 4. What's that, y'all? 16. Times 4, 64. There it is. So I can change 64 to be 4 cubed. Again, on the other side, already got that. And it's raised to the 3x minus 3. So I can drop the base, and therefore 3x minus 3 equals positive 3. Now, solving that, I'm going to add this 3 here. So 3x will equal 6, 3 plus 3. And then I'm going to divide by 2. Or I'm sorry, I'm saying the answer. I got a little ahead of myself. I'm going to divide by 3, and 6 divided by 3 is 2. So that is how easy I plan on your problems being tomorrow. I don't plan on them. It's already decided. So if you understand how to do 7, 8, 9, and 10, you should have 0 problems tomorrow. Okay, 0. Now, if you don't study this, then you might have a little bit of struggle. But they will be just as easy tomorrow as they are here today. So you should be really good shape for page 1 going into the quiz tomorrow. Now let's get to the graphs. And I'm going to knock out a couple things real quick because I want you guys to be thinking along the lines, like for example here. Did this thing have a vertical shift? No, it doesn't. And because it doesn't have a vertical shift, that means that my asymptote does not move. It's y equals 0. Now you're going to see that on the graph. But let's go to our graphing calculator and let's check that out, okay? Now, I told you guys this. Let me see here. I told you that when I have a fraction, I like to change it to a decimal. So I'm going to do instead, I'm going to do 3 times open parentheses because I want to type it just like I see it, except I'm going to change 1/2 to 0.5 raised to the x. So if you look at yours and mine, 3 times 1/2 raised to the x and 3 times 1/2 raised to the x. It's the same thing. It's just decimals with exponents. It's a little easier. So when I go look at my table, it's going to give me values that I'm a little more familiar with. Now, I can't go graph negative 212. It's just not on my my coordinate plane. So I'm going to start right here at negative 1, 6. So negative 1, and then up 1, 2, 3, 4, 5, 6. I'm definitely going to mark 0, 3 because that's my x-intercept or my y-intercept. 0, 1, 2, 3. I've got 1, 1.5. I've got 2, 0.75. And then as you can see, they just keep getting smaller and smaller. So let me go back to my graph. I've marked these points. Hopefully you have as well. But remember, my two rules when I'm graphing this are, 1, go through your points. Okay, it'd be stupid not to go through your points. Try to hit your points to the best of your ability. And 2, do not pass this horizontal asymptote, which is your x-intercept, y equals 0. So when I graph this thing, I'm going to go through my points to the best of my ability. And then I'm just going to make sure and I never cross that asymptote. So there you have it, a perfect looking graph. All right, let's answer some questions. Domain. Now look, I know this thing to the left is going up, but it's also going left. And it's going to keep going up and to the left forever. So does it ever stop going left? No. Does it ever stop going right? No. My domain is unlimited. Negative infinity to positive infinity. Now range is limited. Why? Because it can't go below that asymptote. It's headed towards it, but it can never cross it. So my range can never go below 0. It goes towards it. Now, you can tell for y, it's going up forever. So it can approach positive infinity. It just can't go below 0. So as I answer the next questions, as x approaches infinity, as x approaches infinity, as we're going to the right, what's y approaching? Well, it's going down, but where is it going down forever? No, it's going down towards my asymptote, which is 0. But as x approaches negative infinity, as we go to the left, what's y doing? Well, it's going up. How far up? Forever up, infinity. And then, of course, we already marked this. Our y-intercept, if you go back to your table, is 0, 3. So I can go write that right here. My asymptote is 0, 3. I'm sorry, not that. My y-intercept is 0, 3. My asymptote we already decided is y equals 0. Now that graph is done. Okay? Easy as can be. Now next one, number 12. Number 12. I wish, man, if I had this over, I probably wouldn't have done 1/8, but I did. Let me just show you because I got to stay consistent, and I won't put 1/8 is equivalent to 0.125. So when I go here, I'm going to put 1/8, which is 0.125, times 4 raised to the x plus 1. Now again, I know it's not beautiful. If I'd have done the other graph, it would have given me the same graph. It may have just given me my values as decimals, and generally we just don't like looking at decimals. So that's why I changed it. If you don't want to change it, just roll with it. There it is. Now let's look at the table, and let's see some values that we can do. I can't really do much with many of these. I'll go ahead and do a couple of them. Okay, I've got 0, 0.5, that's definitely important. In fact, I'm going to go ahead and answer that. That is my y-intercept, 0, 0.5. I'm going to write that first. Then I've got 1, 2. So 1 up 2. Then I've got 2, 8. And that's about all I can do besides these real small decimals. So let me go back to my paper and again, remind you, the way we're going to graph this is we're going to go through our points, but we're never going to cross our asymptote. Now, what is that asymptote, though? We'll go back real quick. Does it have a vertical shift? Is there anything right here? No, there is no vertical shift. That means it does not go above the line y equals 0. So just like the last one. Okay, so let's answer some quick questions and we'll call it a day. First of all, asymptote we said doesn't move. It's y equals 0. Our domain. Well, it never stops going left. It never stops going up and to the right. So my domain is unlimited. Your range, again, just like the last one, it can't cross this asymptote of 0, but it can go up forever. And my end behavior switches as x approaches infinity. As we're going to the right, this thing's going up, which we define as infinity. But as we're going to the left, my y is not going towards negative infinity. It's not going down forever. It's going down towards my asymptote, which is 0. So there you have it. That is how you answer all these questions about the graphs, which we have done. We had an assignment about that. Y'all had 3 homework problems over it. We did 2 examples together over it. We've talked about all these terms before. So at this point, you should be pretty comfortable. So that's it. That is your review. This is right now looking like a 26-minute video. So you're going to have about 15 minutes left in class. I would recommend you take this time to study and get dialed in. So tomorrow you will be prepared. So for example, let's say there was a problem here and you don't realize what I talked about. You don't understand it. Feel free to ask a neighbor to explain it to you. That way you can be prepared for the quiz as soon as we come into class tomorrow. Okay? All right. So miss you guys. Hope you had a great day. I will see you tomorrow and we will kill this quiz. If you guys study and prepare, you should be ready to roll. All right? Have a good one.